I Pawan Dubey on behalf of Team Zeroku along with Jamir Basha and Mohammad Mustafa welcome you all to our app which I have created. We have created Zeroku. It is a clone of Heroku that lets you deploy your applications on our website. We host your website and it runs smoothly. So welcome to our application. So this is the first login page, and here I'll be starting with logging in with the account I have already created. Let me show you that right now we can also log in with GitHub and log in with LinkedIn. Yeah, it asks for some device verification code which I'm not going to give. It works perfectly right now. And okay, so let me go ahead and log in through my normal user account that is we have created. Okay, so this is the home page of our application. It is just a simple home page. It does not contain anything. Some slideshow of the images just to make it look beautiful. And if we head over to the dashboard, here this is the main most important page of the website. Which gives you control of approximately everything. Here this is the button that lets you deploy a new app. So let's go ahead and click on it. Okay, so we can name it. Okay, so video check. Okay, so we have to provide in these three fields. We have to provide images from the Docker Hub. So these are the images of my project, of my friend's project, Jamir Basha's project of Slack Pro. I'll be deploying them on this website. So salary image, I'll be using this one, and I'll submit this one. Okay, so what right now is happening is it is pending, and then it will be creating an instance on AWS account and running some configuration files for that to make our app run properly. So I'll head over to dashboard and explain more of the features that our website provides. So right now here we have two of the applications running already. Third one is being created right now, that is in the queue of the salary process. So here we can see that our website says that this is website name of the user that we have provided. We can go ahead and use their website from here. If we want to log in and also anything, we can use their website in whatever the way we want to. And it also provides the IP address, that this is the IP address the user's website is running in, and it says the status, that current status of that instance, actually in which computer that website is running. It allows us these to check logs of that website, that whatever is happening in those website, and we can even filter them with respect to container names. Like we have made three containers, one for Redis, second one for application, and third one for Nginx. So there are three different containers, and we can even filter those logs based on the container name. So here that was the part about filtering logs. And here from here we can also check uses on the instance on which this whole system is running. We can check uses of the particular hardware uses, like RAM and disk space storage, whatever is being used. This API that AWS provides is bit slow. Here we got the result. Out of 1 GB RAM, approximately 1 GB RAM, we have used approximately 341 MB, and this half a GB is remaining. And out of 8 GB of ROM, that is storage, we have used half of them. Okay, so that was it for the that was it for the controls we have from the dashboard. Now we have our app also provides a couple of APIs, to name them 7 APIs to fetch the data that we belong to. So let me head over to my console and use those API. Okay, so the very first API is which you can use is provide a username and password to this to /API/API token auth to get a token for that user account. So I'll be using my password and username to get the token for that account. So this successfully returns a token that says that next time I'm going to make any request, I'll have to use that token as authentication token. Okay, so the next API is I can get all the apps. SAS API/apps gives all the application that have been made on that account, that particular account. Okay, so if I go ahead and click enter over it, this provides this provides the data about list of application that we have made on this account. The thing to be noticed that all the apps are not being run on this particular website right now, but this data has been made, like this is the dummy data. This has been made to check the APIs that they are working fine for multiple values over time. Okay, so now let me go ahead and test some more APIs that detail of a particular instance. To get detail of particular instance, we need to pass API/app/app ID, and authorization token will remain same. So now let me go ahead and find out the currently made apps ID. So okay, so we have gone to the Python manage shell over here, and we have listed down all the apps that have been that are there in the database, and this is the app right here. We have here Slack Proking. We will be playing with it in through our APIs, and to get the ID I had to do all this thing. So the ID for that app is 202. Okay, let me get over the console over here, and let me get the data. To get the detail of that Slack Proking 2, I have to make a GET request to this API, the /API/app/202, and send the authorization token along with it. Okay, and I hit enter. I get the image details of all the Docker files, and along with its name. Okay, so this was it, and after that we have we have 3 more APIs that accepts only post request. The first one of them is if we want to stop an instance with ID 202. Okay, so before stopping that instance, we would also like to make a GET request to see all the logs to this app ID name that is 202. So if you go to /API/app/202/logs, you will be getting list. Okay, so there is no log over here. I don't know why. Okay, yeah, so we cannot have any logs for that one. So we'll be working for logs. We will be going through we'll be using Slack Proking 201. Okay, so that application does not have any log. Probably there might have been some crash on the salary also. So if we go and see the log to 201/logs, we'll be getting all the logs that are there in the that corresponds to that application, particular application. It particular log contains a couple of things like that: container ID from which that log is created, the container name for what image that container is running, and the log itself that says that this HTTP request has been made to this thing or so, and the IP address. This IP address is actually being used to fetch the data from the Elasticsearch data that is being stored on the cloud service provider named Logit, and it also streams that this log is being sent on the standard output, and it also provides the the stamp that this log was being created on 2021 to 120, and this is the time 16:49:03. Let me remind you that this timestamp is on the UTC. Okay, so the next one is, we can also go ahead and stop this instance through the API named /API/app/app ID/stop. Okay, sorry, I made a GET request. I'll have to make a POST request because /stop changes the state of the instance. That is the convention followed in the REST framework. Okay, so if I hit enter now, it updates me with a message that instance stopped successfully. Okay, so if we go back here, we can say that we can see that this Slack proking that we just stopped from our API is being stopped now, and provides two more options, that we can either start the instance or terminate it. And we can also see that we in the starting that we created the video check app. It is now being created, the salary process is done, and we can now go and just, use their website. Okay, so let me just get there and start the instance that we have just stopped. Okay, so here right now what it returns is an task ID for the salary process. Actually, starting the instance means that it has to be started and reloaded all the information that it needs to rerun. That takes approximately as much time as creating an instance. Okay, so yeah, that's it. Now right now if I refresh it, I don't see that it has started, because it is in the process of being starting. So right now if we want to see the function, if that terminates on termination of the API, if we want to check, we can go to 202, that is the ID for this application. Oh sorry, I clicked that one. Okay, that is the ID for this application. If we want to terminate this one, we would just go there and say, and instance terminated successfully. It successfully terminates the instance. If you go ahead and refresh this, that is this app is gone now. Okay, so the next thing we can do here is, okay, so this is the command for creating an instance. We can just make a post request to http://circo.online/api/apps. Okay, so that creates a new app for the token that we provide for that account, and it requires four arguments, four parameters. That's name, that is some random creating app from API, and Docker file. We have again used the same Docker files to create the same app, that just to ensure that everything works. Docker file, nginx image, and salary image. These four parameters we have to provide, along with the authorization token that we have got when we accessed with the post method to that app auth login. Okay, so if we hit enter, it returns us with the task ID of the salary process that has been started for that creation of the instance and deploying of the application. Okay, so that was it for the APIs. Right now we can go there and see that this these are the applications that are up and running. We have said that start instance to this one, and it is now started, and same applications we can even perform from here also. Okay, so we can also perform the same application, same operations that we performed from the API from here also, from the GUI as well. We can stop the instance. The instance is stopped and we have got a pop-up, and we can start the instance, but it will take a lot of time to be started. We can even terminate the instance. Yeah, that instance is gone now. Okay, so the best feature of our application right now we can show you is the donate part. So we have also added a donate button that lets kind-hearted people donate to our donate for our work. So if I type my name and contact number and donation amount of at least 10,000 rupees, so would donate less than that, we can go ahead and it will take us to the merchant page, that is Paytm. We can use Paytm wallet, credit card, debit card, and net banking. These are all the methods that we accept. And we can provide the details here, and we can pay. So this works, but we don't wanna go into the money things. Okay, so that is it. And it also says that user had not completed that transaction because maybe user was not kind enough. Okay, so here is the about page that shows all 3 years as contributors of this project. So thank you all. Now thank you, this was all from my side. Now Jameer will take on to explaining the architecture and workflow diagrams for this project. Thank you.
So here we have the actual architecture diagram of our application. So first the user makes an incoming request. We have a domain name called Zeroku.online. If the user makes a direct request to Zeroku.online, we will redirect him to our own page. So here the user provides the Docker image names. So once the user provides the Docker image names, an instance is created. Inside that instance, Docker images are pulled from the Docker hub. Then a Docker compose file is made and the scripts are run to make the application run. After these processes are completed, we are creating a subdomain.zeroku.online, where the subdomain part is the actual application's name which the user has provided. So this nginx configuration is changed after the application has been created. So once the request comes in the part like subdomain.zeroku.online, where subdomain being the application name provided by the user, we are reverse proxying it into the particular instance the user has created through our website. So we have let's say we have like slack.zeroku.online. It will show a particular instances. It will proxy pass to a particular instance's IP address. Then let's say we have youtube.zeroku.online. It will redirect to another instance IP address. So this is the actual workflow diagram of our application, wherein primarily we have the login and register page, and we have provided login using GitHub and GitLab as well. Then we have the payment or donation page. So to pay or donate, the user does not have to log into our page. Then the user after logging in, the user is taken to the home page, or that where he can go to dashboard to see options like stopping an instance, starting an instance, terminating an instance, to see the logs of the instance, to check the usage of the particular instance. And then we have a create new app, where the user can give the Docker image names. So once the user provides the Docker image name, a accelerated process is started. So inside this accelerated process, these processes run, wherein a new instance is created in the AWS server. Then the port 80 of the instance is exposed, So we make a docker compose.yml file is made from the docker image names which the user provides. So if the user provides only the docker image name of his main application, we put our own generic nginx image so that his application runs. So if the user does not provide a celery uh, image name, so we simply avoid that so that the main application still works. So we are running the after this docker compose has been made, we are running script inside the instance. After that we update our nginx configuration to point to the when the request comes to the particular subdomain, where the subdomain being the application name itself, we will proxy it to an IP address, reverse proxy it to an IP address the user has created. So after this configuration has been completed, the user is provided with the website address. So this whole process, it is shown in the main loading screen of the application where the celery process is running and the instance is being created. Yeah, that's all about our application. Thank you, and do remember to donate us in our donation page.
Database part of the project. So we have a single instance in AWS running PostgreSQL, where we have the user's database stored. So first the user should not give any server name in his nginx configuration, so that we can redirect him with our own subdomain. Then the user has to export port 8000 in his application's docker image, so that we can compose it inside the docker compose file. So the database part, the user has to provide Postgres underscore URL for database URI. So this is an environment variable. So these are the various environment variable which the user should give. So we will provide this environment variable when we do the Docker Compose part. Then the user must include the migration script in the web application image itself. So what happens here is, if the database if the application is connected to this database, so the migration script will check whether the database is already existing in an application or not, and it will start making the migration to that particular database, so that the migrations are done and the application runs.